Welcome to the world of exponential equations, where variables rise to the power of possibilities. Let's dive into the basics of solving these intriguing mathematical puzzles. First, understand what an exponential equation looks like. It's one where the variable, let's say x, is actually in the exponent. A simple example is to x equals to 4. Here, x equals 4. But what if the equation isn't so straightforward? Say, we have 52x equals 56. To solve this, we begin by simplifying the exponents. The trick lies in expressing both sides of the equation with the same base. For example, if we can rewrite 16 and 128 as powers of 2, we're on track. Once we establish that 16 equals to 4 and 128 equals to 7, we can rewrite and simplify the equation using these bases. This reduces the complexity considerably. Next, equate the simplified exponents. From 1 to x 20 equals to 4 x 28, we see that setting 1 to x 20 equal to 4 x 28 helps isolate x. Solving the equation 1 to x 20 equals 4 x 28 leads us to find x equals 4. It's thrilling to see how these bases help unlock the value of x. Let's tackle another example. 9 to x 3 equals 27x plus 4. Both sides can be expressed as powers of 3, simplifying our work. Rewriting it gives us 4x 6 equals 3x plus 12. Equating the exponents, we derive 4x 6 equals 3x plus 12. Solving for x, we find x equals 18. Notice how common bases simplify the process significantly. What about equations with no common bases at first glance, like 3x equals 10? Here, we approximate x using logarithms, which gives x approximately to 0.0959. Moving on to verification, always check your answers by substituting back into the original equation to ensure accuracy. Verification is a critical step. It not only confirms our solution, but also strengthens our understanding of the concepts applied. Now, let's expand our scope to exponential equations where different bases are involved. This requires a slightly different approach. In cases where the same base isn't apparent, we might need to use logarithms right from the start to help simplify and solve the equation. For instance, taking the logarithm of both sides can be immensely helpful when dealing with bases like e, the natural logarithm base. Applying logarithms, we convert multiplicative relationships into additive ones, which are often much easier to handle. Once we have our equation in logarithmic form, the process of isolating x becomes straightforward, similar to linear equations. After isolating x, we solve for it just like any other algebraic equation. This might involve further simplifications or solving quadratic equations. Remember, the key to mastering exponential equations lies in practice and understanding the properties of exponents and logarithms. Always double-check your work. Verifying each step can prevent errors and solidify your solutions, ensuring they are robust and accurate. As we wrap up, reflect on the journey from recognizing the type of exponential equation to efficiently solving it using various strategies. Thank you for exploring the fascinating world of exponential equations with me. Keep practicing, and soon you'll be solving these equations with ease and confidence.